All right, this is the video that is on solubility rules and precipitation reactions. So welcome back, and let's get started. This one hopefully will be shorter than the last one. Okay, so first thing I want you to do is write your vocabulary words in your journal. This we have soluble and insoluble. Okay, so write these in your journal. Soluble means it will dissolve and become an aqueous solution. So we're going to have an AQ. Okay. Then insoluble means that it will not dissolve and forms a precipitate or a solid. Okay. All right. So moving along. Make sure you stop this if you need to. Okay. The next thing we're going to talk about is not all ionic compounds dissolve. So we have to have these things called solubility rules. Okay. I'm going to give you a chart in class, and hopefully you'll have it before this video, but if not, I have one in this video for you. Okay. Instead of doing experiments all the time, we have this thing called a solubility rules, and we have a chart that we follow. So some of the solubility rules, you don't have to write these down, I'm just going to go through them, is that all nitrates, you can write them down if you want to, but stop the video if you're going to. All nitrates are soluble. Okay, nitrates have an NO3 at the end. All ammoniums are soluble. Our carbonates, phosphates, and hydroxide are insoluble, except with certain cations, and they're in the rule number 2. So all chlorides, bromides, and iodides are soluble except with certain elements. All sulfates are soluble except with other elements. Okay, so you don't have to write this down unless you want to. But here is our solubility chart. And let me move this. Let me see if I can move this over a little bit. Okay, so this is what your solubility chart is going to look like. And hopefully in class that you will do this. We're going to put an AQ here. Okay, this is how you read it. So everything on this side is soluble. It will be a liquid-looking substance because it'll dissolve in water. Here are our exceptions. Well, if you notice right here, these right here, lined up, do not have any exceptions, so they're always AQ. Okay, these 4 right here, bromine, chlorine, and iodine, and sulfate, have exceptions. So when they are combined with silver, lead 2, and mercury 2, these 3 right here, they will be solids. When sulfate is combined with these down here, they're going to be a solid. Okay, so that's kind of how you read this. We're going to do some practice in class. Down here, there's a line. Down below the line, everything on this side is a solid. Okay, everything that's on this side is AQ. So if it is bonded with something on this side of the solubility chart, it's aqueous. Okay, why is this important? Well, to predict the products of the following reaction, here's the thing you got to know. If no solid, I would write this down. If no solid precipitate is formed, there is no reaction. Okay, so basically what we're going to do is we're going to take 2 liquids, put them together. If a solid forms, there was a reaction. If no solid forms, there is no reaction. Okay, so if we get a cloud, like a cloudy substance, then it's possible that it could settle out and go into a solid. If it does, it's a reaction. So what we do is we look at our product. We look at our 2 reactants, and it is these are all double replacement reactions. So they're going to swap partners, switch partners. So the cation is going to switch with another cation, and so we're basically taking lead and switching places with potassium. And when we do that, we end up with lead iodide, and we're going to get potassium nitrate. Now, if you go on that chart, let me go back. We have lead iodide. So you go up here to this chart, you find iodide. Okay, iodine right here. And you look right here, and there's lead 2. How do I know it's lead 2? Because there's a 2 here. Okay, so that tells me it's lead 2. Lead 2 is insoluble, so it's a solid. The other one is an aqueous. Okay, so it would have a reaction. There would be a reaction here. Okay, so let's do some predicting products. Okay, let's actually do some. So our cations are going to change places. Okay, first thing we need to do is come up with our oxidation numbers. So lithium has a +1 charge, chlorine has a negative. Silver has a +1, nitrate has a -1. Okay, so all of these are 1s, so they're gonna just basically combine. So when we predict our products, lithium is going to go with your nitrate, and your silver is going to go with your chlorine. Now we have to go back to our chart and see if this is working. So I'm going to look for my nitrate. So I'm going to look up here. I'm going to find nitrate, NO3. There are no exceptions to this rule. So when I do this, this is going to be an let me put it down here, AQ. Right? Silver chloride. I got to go look at silver. So I'm going to go back to my chart, and I'm going to find silver. I don't have silver, so I have to look for chlorine. Well, here's chlorine. Oh, look right there. There's silver. See it? So when we go back over here, this is my solid. So you have to use that chart with it. Okay? So let's take a look at this one. We're going to go lead and sodium. First thing you want to do when you're predicting products is find your oxidation numbers. Well, I know that nitrate, if I look on my polyatomic ion chart, has a -1. This 2 started out up here. Remember, crisscross, come down. And then sodium has a +1. Iodine has a -1. Okay, why is this important? When I go back over here, remember I've got to take my oxidation numbers with me. So what's going to happen is lead has a 2+ charge. It is now going to combine with iodine, which has a -1 charge. You crisscross them, you end up with PbI2. So that is my product, PbI2 plus. Well, then this one's a 1 and this one's a 1, so it's going to be NaNO3. Okay, now I got to go back to my chart. I'm going to look for iodine and see if iodine is with lead. Oh, it is. It's a solid. This reaction will take place because there's a solid. That means this one has to be an AQ. We cannot have two solids. Okay, so that's another thing. So make sure you have my examples. And if I'm saying something like one is a solid, once you figure out the solid, the other one's an aqueous, you might want to write that down too. Okay, so here's your turn. You're going to take and you're going to predict the products. So basically, you're going to predict the products on each one. Bring it to class. Don't forget your charges. Your charges. Okay, it is a double replacement reaction, so the cation ions are going to switch places. Those are the ones that have the cation ions, if you remember, have the plus charges. Okay, this little video I thought was going to be shorter, but it actually is longer. But it is really important. So bring it to class, and I'll see you in class.